All right. Hello, everybody. Um, how's it going? Nice to see you all. And by the way, this is like, I don't know who's ever been, like, is this normal? Are there conferences that happen in like these sort of venues? Because it's pretty amazing, honestly. So, um, anyways, thank you to Dev Days, whoever all organizes. Pretty sweet. This is my first time in like Vilnius in probably like 20 something years, and it's really freaking nice. It's pretty awesome. So, all right, let's do this thing. Me, I am wearing even the same jacket, except it has many more patches on it. You can see, but that's me. Thankfully, you have a picture of it right there. Now you definitely know. So my name is Dan. I've been doing this for about 20 years. Plus, I've been saying 20 years for about like 5 years. So I think it's more than 20 years at this point. But I've been doing it for a while. I've been doing software and systems, and I say systems because I'm not really a traditional software engineer because I spent a lot of time in data centers as well, doing R&D. So doing really weird esoteric stuff like dealing with, I don't know, redundant power, PDUs, monitoring switches and networks and all kinds of super weird oil, like generators, diesel generators and stuff. Reverse engineering, SNMP, and all kinds of weird stuff that like normally you shouldn't really be doing. So basically, and I am fairly comfortable in most popular like languages as well. But with that said, I have been doing stuff in Go for the past 10 years because ever since I started doing Go, I never stopped. It's actually the best language, pretty much. There's no point in actually having any other discussions here. The best language is Golang. The end. Like, so thank you very much. So I'm just kidding. Like, but Golang is pretty sweet. Yeah, yeah, woo, yeah, done. Cool. Usually, I don't really do non-technical talks or like not like super deep divey talks. I'm pretty nerdy. Like, this talk is not super technical, but when if it would be, then I would be doing a talk about event driven and about asynchronous things and about event sourcing, and that would be incredibly fascinating. As I have now learned, people just love talking about event sourcing. There's the joke was that there's dozens of us. So anyway, but today I'm not talking about event sourcing. But if you want to talk about event sourcing, we can arrange some things. So I am from Portland, Oregon, USA. Somebody told me I kept saying Seattle before, but like people said that like they probably might know about Portland, Oregon, so I started saying Portland, Oregon, I guess. But if you don't know where Portland, Oregon is, it's next to Seattle, so on the west coast. But I'm originally from Riga, Latvia, and I'm actually going to be going over there in a couple of days. So, all right, let's go. Let's go with all this. So, and yeah, I've been at a few companies doing all this stuff, so have a bit of experience as well. But all right, WTF? What do I mean by performance review, right? So here's the thing. It's not like a soft thing, right? Like we're not talking about like soft skills about teams and so on. This is totally about code optimization, really. Um, Basically, the point of this talk is to review the state of performance requirements and generally unnecessary optimization in enterprise backend software development. And this is a concept that's kind of close to my heart because it has been going on for like I don't know how many years. I've been doing this for like yeah, for quite a while, and it happens every couple of months, right? Like that I'm in a bar drinking with somebody, and somebody's like, "Well, you know what I did? Hi, I decreased the performance on, or like increased the performance on this from 200 milliseconds to 180," and you're like, "Oh, okay, nice." And I think it's a total waste of time, especially in 2023. So that's what this talk is really about. I just wanted to really pinpoint it. With that said, I spoke to some people, some people over like in a couple of rows here, that mentioned that like they kind of did like a really like is performance really not necessary at all? In some cases, it's important, yes, but for the vast majority of us, it's not that important anymore, and that's what this disclaimer is about. So, I am specifically talking about, by the way, I'm sorry. Like, you rock, man. It's totally fine. Like, so. All right. I am specifically talking about HTTP stuff. Like, so very simple, the type of services that most of us write. Like, the HTTP request response based things. Like, they are generally stateless, that's what this is about. Like, most of us write that. I've written about, I don't know, 30, 40, 50 of these services in my career, like just tons of them. And that's where usually there's these crazy optimizations. So I think we're specifically talking about like SaaS, right? Like, that's really what it's about. In some cases, if you're going to be doing uh, games, fintech probably like the fintech, certainly milliseconds matter big time, right? But for the vast majority of us, I don't think it's that big of a deal. So I'm putting this out there as well, that like I think that under 250 milliseconds is fine. Like, for the stuff that I'm doing, it's okay. It's not great, not terrible. If anybody's watched the Chernobyl thing, it's pretty sweet. And it says not great, not terrible. No? Did anybody know? I should have put that on here. There's a doctor that says not great, not terrible. Anyways, well, that's on there. So not great, not terrible. I also think that several magnitudes of a change is not really an optimization. I think that that's really should be considered an improvement. So going from, yeah, if your service that's just doing nothing basically is taking 7 seconds to respond, and you're like, man, I'm gonna optimize it to be 200 milliseconds or 100 milliseconds. Nah, that's not really an optimization. You're just like fixing it. Like, you're making it okay. And then after that, going from 100 to 50 milliseconds, I guess that's the point that I'm talking about. There's no point. Who cares? Doesn't matter. And I'm really assuming a couple of things here as well. Is that, well, I assume that folks here are comfortable with threading. And that means mutexes, semaphores, async, those sort of things. Like, because we've gotten to a point now, and writing code in general, and there's so many high level languages that make this so simple. Cough Golang. That everybody should be just comfortable doing it in the first place. So I just kind of assume that, like, well, it's kind of normal. And I also assume that, well, everybody's just able to write decently performant code from the very beginning by default, right? Like, just being aware that you're not going to write some piece of garbage that takes like 3 minutes to respond or whatever. Like, what are you even doing? What's the point? Maybe you should do, I don't know, something else. So, great. So that was a very nice way to start this. So I guess the TLDR here is that in 2023, I believe that in-depth performance optimization can be generally ignored. There's some peppers around there, little peppies, a couple, like an asterisk in there as well. It's like, if you can barely read that, it says for traditional web services. That's what it's about. So for traditional web services, right? Because, well, there's totally some places where it's still going to be needed. So, and just to look at this a little bit further in, I wanted to just double check and see, like, well, are the search analytics like the same? Are they saying the same exact thing, that like that people don't really care about optimization as much? And guess what? The answer is exactly that. Like, if you look for performance optimization, it goes down. If you look for memory leak, it goes down. This is from 2004. If you look for valgrind, if anybody is doing some C, all my C peeps in the house, doing a little bit of memory leak, like lookups, yeah. All right, valgrind. There's a few other ones, but I couldn't figure out how to fit them on the slide. But I just looked up random stuff, and it's all going down. So it's the thing. I am not totally crazy that I'm talking about this in the first place. It's totally a thing that optimization for the general part is like. It's kind of like, I mean, you'll still need to know about profiling, but it's not going to be or it's not as big of a deal as it was before. But I think, so besides the TLDR, I think we should be really digging deeper to understand, like, well, what actually exactly happened. And I think the way we can look at that sort of stuff is by looking at the timeline. And I think it starts a little bit earlier than the 90s, probably like about 80s, but that was like, I don't know, that's a little too much. So going from the 90s, that's like a fun time. So I basically just wanted to see if there's like some sort of a pattern, really, like what caused all this stuff in the first place. So it's just like random facts, okay? So the random facts are that, well, object-oriented really just started becoming kind of a thing, like in the 90s. Object-oriented was already invented in the 80s, but it only started catching on more and more in the 90s. Um, and at that point in time, also Fortran and COBOL were still kind of a really big deal. They were pretty much the dominant language still, like back then. So, um, Java was released in 1995, which is when O really was like went a little further. Um, SOA, service-oriented architecture, really only started first appearing in 1998. So let's say for the most of the 90s, it's like it basically didn't exist. We're talking about some pretty rudimentary stuff, right? Like computing in general is kind of lame. There's nothing really cool happening yet. Um, yeah, so SOA not the norm. Microservices certainly did not exist, or even services did not really exist. I mean, people had them, but they didn't think of them as services. Um, and the first time that somebody mentioned microservices was in 2011 anyway. Cool. REST, as you would guess, was not even a concept at all. It first was talked about in 2000. Public APIs, definitely not a thing at all yet either, right? And everybody's doing monoliths all over the place. And here's the thing that I was just looking up. I just stumbled into it actually. BBSs. If anybody did BBSs, if you're in Latvia, you couldn't call, like, it would probably be super expensive to call into a US-based BBS. But if you're in the United States, there's a lot of BBSs. Like there were 45,000 of them in 1995, which is completely crazy. So, but anyway, it just shows that the state of 1990 was pretty meh. And the way we were deploying stuff is we were deploying stuff onto bare metal servers, right? Cool. Moving on to 2000, things are getting significantly better. Popular languages are C++ and Java, as you'd expect. Tons of stuff is written in PHP, and Python is totally becoming, well, it's already fairly popular, I think, but even this works perfectly with my own experience as well. Is that like I think for the beginning of the 2000s, like 2000 to 2008 or so, like I was just writing Python every day, and uh, and that basically mimics exactly what was happening in the industry as well. Python and PHP, but we don't have to mention that second part, but we did. Um, yeah. I could talk about PHP as well in a separate talk. Man, we can have a great conversation. Like that language. Oh boy. All right, Rails is released in 2004. That obviously starts changing things up pretty dramatically as well, and things are becoming more modern. But around this time, we are beginning to deploy onto virtual machines. So I guess you can start seeing the pattern here. Is that like they're getting more complex, because certainly procedural languages that don't have OO are certainly easier than OO languages, and yet we're okay with it. Similarly with deployment, deploying onto virtual machines and understanding like hypervisor levels and blah 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 and all this stuff, like it's way harder, like where it's way more involved, right, to even understand it in the first place. So let's go to 2010. So in 2010, that is, I didn't even put a year down here, but it was like 2011 or something like that, where there were actual papers discussing the separation of backend and front end. Like no longer you had a single app that basically did everything. All of a sudden it was just like, there's going to be dedicated apps for specific things, right? Ruby is, well, more popular than ever before. There's like Rails is proliferating absolutely everything, and finally PHP is on a downward trend. Perl is much less of a thing, but still exists no matter what. Still exists today as well, like all the time. And Kubernetes is released in 2014, and this is, I think, where we see like the biggest shift really is that like we are now deploying, instead of virtual machines, we are deploying like onto something that is like container-like. So whether it's jails, chroots, LXC, yada yada, all this thing. Like I was talking to somebody just the other day that Solaris, for instance, it was the first one that had jails already, and they had them in like the 90s. They were basically like fancy chroots, and they're like the beginning of containers essentially, right? And we finally said, yes, let's do this thing with containers to begin with. So Docker, and Docker obviously took it to a whole next level, right? It basically made it mainstream as well. But Docker showed up in 2013, so the rest of the 2015 plus and so on got pretty funky and pretty sweet. So um, again, what we're seeing is that everything is getting more is getting significantly more sophisticated, right? And Kubernetes is even like starting to become a thing as well. And I think this is also where you start noticing that like, okay, CI pipelines are no longer just like a Jenkins job that's doing something. It's like Jenkins jobs in plural that are doing functional tests and doing integration tests and doing all this stuff, and then ultimately maybe doing continuous delivery, maybe doing continuous deployment, even that sort of stuff. And it became a normal thing. And again, it's all about things just getting more complex. And finally, we're in 2012, 2020, or 2020s, 20s, well, whatever. Kubernetes is the norm. And before K8s, there was Mesos. I don't know who's used Mesos. Guys, what did you use before Kubernetes? Do people know Mesos? Huh? Anybody know Mesos? All right, cool. There's one of you. Great. Like two. Yeah, there's Mesos and there's LXC and all kinds of other things. Again, people were trying to, again, orchestrate things and so on and make things, again, more complex in exchange for stuff, right? Auto scaling also becomes a norm in 2020s. That's like I think it's a fairly big deal by itself right there, because all of a sudden people can understand that it's possible to save money, right? Even though you might need at some points of time like some sort of behemoth hardware, right? So that becomes a thing. And I think that a really important part here is that now distributed systems and like distributed system like concepts are fairly normal. Like it's not that weird to talk to an engineer and be like, oh, let's talk about distributed systems. Like everybody knows generally the term distributed systems, maybe not every single concept in there, but like generally speaking, people are more familiar with it. And the thing is that by this time, like now, there's a ridiculous amount of stuff that is distributed by default. I just randomly put stuff on here, and there's like in Cockroach and Storm and Pulsar and Kafka, Cassandra, and so on. It's just like the list goes on. This is just literally I was just putting putting everything on there. But there's tons and tons of stuff, and it's all distributed from the very start. So. Likewise, the monolith, like, I mean, people still have monoliths for sure. That will still happen, like, but it's all legacy stuff. But in general, like, new things, people are not really building monoliths unless there's an incredibly good reason why it actually needs to be for, like, business reasons and so on. But generally, it's not really in vogue anymore. Microservices are the primary thing that rules the landscape. And, there's tons of REST APIs, right? JSON is all over the place. JavaScript is all over the place. There's new frameworks for JavaScript coming out weekly, bi-weekly, something like that. I think I learned, somebody was telling me about some framework, okay, even today. It happens all the time. So, and here's a reminder, like I just got reminded about like Roller Coaster Tycoon. That dude wrote this entire thing in assembly in 1999. And I remember there was like a big thing about it is that it worked on absolutely anything. It didn't matter. It worked on absolutely every single thing. And I think the parallel that I'm trying to like get to here is that we don't need to do this at all anymore. Like this is like massive over optimization for I mean, he didn't look at it as over optimization because he just knew assembly. So he just had to do it. But for us, there's really no purpose for this anymore at all. Like there's so much stuff that's like available in high level languages and so on that like this is totally basically doing it too much. So and yeah, it's not the 90s anymore. So I guess what I've been saying this entire time is that I think that we are okay with complexity if it is in exchange for improved performance and reliability and scaling. That's really the underlying thing, and I think that we're talking about, it's almost like a philosophical talk about, you know, human nature and how we advance and how we do things, and things just we just like more complex things if they give us something in return, that sort of thing. So I think that's what all of this is about ultimately. And so we have arrived at the ultimate point of all of this is that I think these major milestones, like all these things that we just went through, the 90s and the 2000s and 2010s, like, yeah, 2010s and 2020s, is basically been just leading us to two things, which explains why well, why, at least why I think that optimization is not really even necessary to begin with, or again, with an asterisk, put that in there. So it's all these different advances and so on have made us be okay with being stateless. That's like the big takeaway here, right? Is that everything has become stateless. So I don't know how many of you remember, but there are like sticky sessions and yada yada, all this stuff that we had that we just made sure that like, oh, this person that's loading this website is definitely on this same server. That is gone. Like nobody wants to do sticky sessions anymore. It sucks because you can't. Well, it can't be state like it has state all of a sudden, and all of a sudden now it's difficult. It's much more difficult to scale it. Yada yada, all those sort of things, right? Um, and ultimately, well, all of this stuff brings us to being able to horizontally scale. And prior to that, like in the 90s, everything was vertical scale. Um, I'll put it out there. Vertical scaling, adding more CPU, adding more memory, right? That's it. The end. Like you could just go up, adding more disk. Horizontal scaling doesn't matter. Like you could just scale additional replicas of stuff, right? And that's significantly nicer, but it requires that like in general you've been writing architecture, like the architecture of your software is stateless, right? That it can be executed by one place, by second place, third place, fourth place, doesn't really matter in what order and so on. Um, so yeah, like a very basic example of this would be that your service that used to require 8 gigs of RAM, like let's say 4 CPUs, like some dedicated machine that all this was running on now, you can, well, distribute it across 4 replicas instead, and each one of them would have like 1 CPU, 2 gigs of RAM, and you can just, instead of putting up another machine with 4, with 8 gigs of RAM or whatever and 4 CPUs, now you can just like nicely just fine tune this thing or whatever. So pretty obvious. So I guess again, what I'm saying now is like that, like instead of actually optimizing the software and trying to cut off, some 10, 15, 20, 50 megabytes, or even a gig or something like that, of memory, it doesn't really matter. You just like add more replicas. Memory and CPU is basically cheap, like, so who cares about all that stuff? I was also doing some stuff about. I just did this quick example. I just for myself, I wanted to see like how much would it actually cost, right? Like in the simplest possible way. So if you have like in terms of how much time you put into something, how much does it actually cost you? Well, let's say as a business, right? So in this scenario, if you have like a lead, staff, whatever, principal engineer, who let's say spends some 40 hours optimizing something to try to lower memory and CPU usage, well, let's say they on average would make like I don't know 250K US a year. Um, they are working ultimately, let's say around 2,000 hours or something like that for the year. Generally, they're making about 120 bucks an hour. And if they spend, 40 hours on optimization, then we basically have spent about 5 grand on, that's what we've spent as a business on this person doing all this work. And just as a direct reminder of this is that, like when we're talking about optimization, uh, a box with 4 CPUs and 16 gigs of RAM would cost us about like $1,100 a year on EC2, and I think it's like a nice nice way to compare this is that the amount of times that I have saved, like I have done optimizations multiple times as well myself. Our entire company has, and lots of engineers have done this stuff as well, but we've never actually taken the time to think like, well, how much like actual money did this save besides making me feel really good? And like then I'm just like I'm so fucking smart. Like yeah, like I don't want that. So that's what this is about. So Uh, I guess there's multiple ways to put this formula out there. Probably somebody smarter than me could come up with like a real formula for it, but it would be uh, the overall result of the optimization. It certainly has to be above at least 25% of the engineer's salary, and I think even then, yeah, it's really difficult to compute it in advance or to be even semi-proper about it in the first place. So, with that said, I think that optimization is still around. It is just very different. It's no longer trying to optimize cycles, trying to optimize CPU usage, and working towards specific architectures and so on, or making use of specific architectures. Now we're doing things like, again, in our very specific space of doing web services and so on, it's about lowering the number of hops that you have between dependencies, or lowering the number of dependencies that you have. Instead of like 15 dependencies, now you have 5, and thus you've lowered the number of hops that you have to do, which is going to be, let's say, like 25 milliseconds every time or something like that, or 10. You would also want to lower potentially the request and the response sizes. So that means that you would move from JSON over to like message pack, or to like some sort of a binary encoding to remove all the cruft that JSON has in the first place, right? Like, because JSON by itself is ginormous, really. I was at New Relic, and I remember we did this exercise where everybody wrote down the dependencies that they had, and we basically just came up with this massive, ginormous spaceship that we like just drew on the whiteboard, and and then like a bunch of network engineers gave us stats for all this stuff. So it turns out that basically the long story short is, turns out that each service had at minimum, like I think it was like five or six, or five, six, seven dependencies, and the average amount of traffic that they were doing at any given time was about was it two? Yeah, it was 2 megabytes. So about like 20 mbit or so that they were doing just in chatter, just chattering between all these different services, and that was like a huge point where basically New Relic did thrift, which is, it's okay. Thrift, yeah, thrift is thrift. If anybody's familiar with thrift, thrift sucks. It's like it's actually pretty terrible, but it is binary encoding, which is that's good as well. But protobuf didn't exist yet, I don't think. So anyways, those are the sort of sort of things that you would do. Another big one is for optimization is stuff that I don't even see terribly often, but like there would be so much more value in updating your libraries or your services to be able to deal with network interrupts. They happen all the time, especially on the cloud, like when you have AWS just basically has like a little blip, that happens. Like there's packet loss and nobody can explain it. But you need to make sure that your service is actually able to recover from that sort of a thing. Or failing dependencies. So we're talking about things like circuit breakers, basically, or like Hystrix style circuit breakers, that sort of thing. And in the end, the other big thing here is that, well, not everything can actually be distributed or allow horizontal scaling to begin with, right? There are definitely like long-running non-stateless jobs like PDF processing, whatever is rendering images or videos, yada yada, that sort of thing. So basically, background jobs, right, that are basically extremely singular. Obviously, old large architectures as well. By the way, what am I doing on time? Do I still got time? Huh? All right, I got this. Got this. Okay, old large architectures, and generally, it is often to just go, well, it's easier to just go vertical and just to say like, nah, here you go, here's your 8 CPUs, or here's your 16 or 32 CPUs or whatever, than re-architecting and reworking absolutely everything, right? It's just that's just, it can be an answer, and it might be a totally valid answer as well, right? When that said, I still put it out there that figuring out, well, even the idea of being able to figure this out, that like, well, this is not even a possibility, it is still a way to really expand your skills, right? Like being able to identify, like in this particular case, this doesn't make sense. It doesn't make sense to try to go super stateless and yada yada. It's like essentially like a path to principal engineering, that sort of a thing as well. So there's definitely something worth to it as well. And at the same time, the other side of it is also knowing how to profile stuff, knowing how to improve, like what you would do to try to improve performance in the first place. It's cool. It's good to know it, no matter what. Like sooner or later, you're probably going to have to do it if you haven't done it yet. And profiling in each whatever language that you're working in makes sense. It's a good idea. It's a good skill to actually have in the first place. So, all right. So, wow, I do think that I actually went through this pretty quickly. So, all right. Conclusion is that performance optimization can be an expensive time suck, and that has happened to me multiple times. It's Yeah, you should just be aware of it. Like that's the thing. And I think in many cases, like performance optimization is like it's totally like a trophy. Like you're just like, yeah, I rock actually. I know how to do this. Like yeah, knowing how to use Valgrind, and like how to like squeeze basically more or in the case of Golang, I don't know, being like an expert at reflect and knowing how to do pointer arithmetic in like Golang, you can do some like pretty unsafe stuff even in Golang to like optimize things, but maybe you shouldn't. Like it's just not like what's the point? Like ultimately, again, it might be that you do need it, but just being able to even identify that sort of a thing is important. Um, the optimization trap is like, or being aware of the optimization trap. What I'm talking about is well, as engineers, I think that I'm not sure if there's anybody worse at figuring out how much time is something going to take. Like when we're trying to like estimate things, we are horrible at it. Like I am always like, this is so easy. This is an hour max, and then it's like 4 days later. So like, and it happens every time, and especially for optimization. Like there's stuff that I am like, I can in my dreams, I can write threaded code, no problem. And then I'm like, I know exactly what's going to happen here for this thread, like set of code. And then it turns out, well, actually, like there's really big reasons why what I thought is not the actual case. So it's basically the optimization trap that you always think that it's going to be easier, and it's never easier. It's always harder. Um, and this is like a thing that I've talked to like CTOs at other companies and stuff like that. That ultimately, we're all here to like provide value, right? Like provide value to the actual business. Like basically, let everybody make more money. And the thing is that the optimization, like it's just you need to be aware of the fact that are you really providing like value? Like just by optimizing something, is it that big of a deal? So, more like, yeah, saving CPU cycles even a thing, right? Like, or does it do anything? And a big one is that, well, I don't know anybody besides Google that is Google, and tons of people I mean, there's like books out there that is like, yeah, the SRE handbook by Google. I get it. It's pretty good. It's cool, but you are not Google, and neither am I, and I will not be, and I think everything, like, again, the philosophical part is that absolutely everything in life is like, it's not black or white. There's a little bit of gray, a little bit of surfing on the gray. All right. You surf on that, and man, I forgot about. I was thinking about surfing. Hold on a second. Um, yep. Okay. Gray area. Read between the lines and take it with a grain of salt. Basically, that like even though there's best practices out there that are written down about, well, this is how Google does it. You just go like, well, cool. Thank you very much. Kind of applies to me, but not really. That sort of thing. I think a really big thing is I come from the observability space. I've done lots of Well, I know a good chunk about observability, and I think like time series and metrics, that sort of thing, like runs in my veins. I really like it. But the thing is, like lots of folks optimize, well, just on a hunch, and they're not actually looking at like hard, cold truth. Like looking at metrics and seeing like, this is clearly showing that there's a problem here, and you should totally do that. So that means like Prometheus, whatever. It doesn't even matter. Put an APM in there, put a new relic in there, put a data in there, put it whatever you want. Doesn't matter. Just put something in there just to see that, like, is this for real? Is this really a thing? Um, so and then so yeah, monitor your apps. Basically, that's what it means. And this is a thing. This is not even an optimization. This is like in that same vein, just figuring out value, right? Like whether it's worth it. Is that like if you have a container that like some service that gets killed once an hour, it's probably bad. You should probably fix that. That's not good. But if it eventually will get killed after about a month under some weird edge case, like maybe it matters, sure, but like maybe it doesn't. Like it's not that big of a deal. I'll give you another example. At a certain company that will remain unnamed, it's definitely an observability company, and I'm kind of familiar with. So at this company, there was this Java service, and it was using something like 250 gigs of RAM or something like that. It was pretty beefy, and I remember there was this whole effort. Like it went on for 2 months, 3 months, or something like that, of folks trying to figure out like why is there this memory leak, like what to do with this thing, and as far as I know, well they gave up. They couldn't figure out the memory leak, and they just said, well, it's fine. Like whatever. Gets killed like once a week or once every 2 weeks, and they just upped the machines to having like what is it, terabyte of RAM or something like that, and it didn't really matter. It worked great. Still a thing. So, anyways, just putting that out there, and that kind of stuck with me because it totally shows the case that like the business value of fixing this mem leak, which is yeah, it's like it kind of hurts a little bit. Like of course it's gross, it's horrible. Like that there's like such a nasty leak or whatever. But still, it's not really that big of a deal in the grand scheme of things, especially if your stuff can restart and survive and that sort of thing. Um, and I think a really big deal here is also figuring out like what is good enough for you, right? Like figuring out what is a good enough metric that is like not amazing. Like you can, I mean, you can define what is amazing. You can define what is like horrible, but that good enough thing where you can say like, I'll just move on. Like I'll just work on something else, or whatever, and just figuring that out in terms of how long is it? Like, what is an okay request time? What is an okay response time? What is an okay amount of memory to have? What is an okay amount of CPU to have? And yada yada. Whatever sort of other metrics that matter to you. Just figuring out like having it written down on like in some documentation somewhere that's like that's what you believe in. It's going to save time. That's really all this is about, and saving time, and that ultimately saves money and stuff. So, all right, is that it? Yeah. So that's me. Okay, that's not me, but like that's a we've got this badass designer that's like working for a company, and he's just like, check this out. I was like, I want this guy. I'm gonna put him in here. So. I usually talk about, like I said, about evented stuff, about asynchronous things, and so on. And most recently, I started talking about WASM as well because kind of jumped into that. I've been diving deep into and swimming through the parts of WASM, which are a little bit hairy. But yeah, come talk to me if you're into that. If you're into evented stuff, or if you want to talk about software architecture, yada yada, that sort of thing.